Okay, so in this clip, we'll go through how to create the actual forecasts. It's kind of the bread and the butter of the project. Using, again, the three models we're going to use are purchasing power parity right here. Then we're going to take its forecast error and then square that error. And then we'll do interest rate parity, basically uncovered interest parity to be precise. Take the forecast error, which is this column here, and then square that. And then we'll do what's called a first order autoregressive forecast. That's a favorite technical name, a fancy name for just it's a version of a naive forecast, which is basically, what's the exchange rate next period? I don't know, just use this period's exchange rate. Okay, and then we'll take the error of that and then square that. Okay, so how do we get this purchasing power parity? Where do these numbers come from? Comes from theory, right? So let's go back here. Let's do purchasing power parity implied. That's what I'm going to call it. So we're using purchasing power parity relative. We're using its relative purchasing power parity. What is that? Remember the theory? It was S equals inflation. So the percentage change, just percentage change in P minus the percentage change in P star. Where P star is foreign, P is domestic. So the percentage change, I can write percentages, right? This is inflation, US inflation, UK inflation, in time period 1, time period 1, time period 1. But if you go to the other part of Blackboard and get the write-up on this, the introduction to this, we can use the expectations, the way that investors formulate their expectations, to get that this is actually the percentage, like the expected percentage change. In other words, so future percentage change. In other words, a forecast. Can explain that in that write-up. And then if you have any questions about it, of course, you can ask me or email me or something. So this is what we're using. How do we do this? Okay, we need an inflation differential. Okay, we can't start here in this cell so we can't have a forecast here because we don't have an inflation differential here. This is blank. Okay, this guy is gonna, whatever comes in this guy's cell is gonna come from, if I go over to inflation differential and go up, this guy right here. Okay, so that's what we're gonna do in this cell, right? So this is the spot rate in Q2, the average. The spot exchange rate is a daily figure, right? It comes out on a daily basis, actually per minute by minute basis, strictly speaking. But this is a quarterly, so this is the average of all 90 days within that 3-month period. Okay, this is what it actually was. Okay. Now we can predict, in a sense, right? We can get a benchmark of what it should have been. That would be this inflation differential here, right? So we would expect, right, it should be 1.7144% lower, right, if you recall from the homeworks and the quizzes. So again, we can use this as a forecast from the previous one. Okay, so for this exchange rate here, the actual exchange rate is 1.2741. I can get a forecast based off this number here, 1.7796, and this inflation differential as to what this should be right here. Let me explain what I mean. So, equals should be this guy times, so the actual exchange rate is 1.7796 in quarter 2 in 1982. And then say we're in that quarter back in 1982 and someone says to you, what's going to be the forecast next quarter? In other words, what's going to be the forecast of the spot exchange rate in quarter 3 of 1982? You say, I don't know, but one way to develop a forecast is to say what was inflation this quarter, that's this guy here, sorry, inflation differential, and that's how much it would change. This is the percentage change by how much it would change. Okay, so 1 plus this guy divided by 100 gives us this forecast here. Let me explain what I did. So here's the equation. See, it's nice. Excel is nice. It highlights this. Here's what the actual exchange rate was in quarter 2. Given that we had this much inflation right here in quarter 2, we would expect then, again, if you read the write-up, it's spell it out a little clearer there. We would expect then that the spot rate should decrease by 1.71445%. Okay? How do you show that mathematically? That's what this formula does here. Right? Here's the spot rate, B3. Here's cell B, column B, row 3. Here's cell B3. I'm going to multiply this guy by 1 plus this percentage change. Or sorry, this percent right here. Okay? Now I need to get this in decimal. That's why I have this divided by 100. I could have created a separate column dividing this column by 100, but I chose not to do so. I can just do it in one step here. And so again, I'm taking the exchange rate from last period, and I'm sort of scaling it up by this factor here, which comes from the inflation differential. Again, which comes ultimately from relative purchasing power parity. Okay? So I can do the same thing for the next period. See what it's doing? What's my forecast of 1982 quarter 4's exchange rate? Well, I'm going to take the previous quarter's exchange rate and scale it up, basically multiply it by the inflation differential here, which is what I'm doing here. This is I4 is. Right, so what this column right here, this PPP implied, is saying is that next period's exchange rate should be today's exchange rate adjusted for today's inflation differential. Okay, and again, this comes from chapter 2. We went through all this in class. This is just showing you what it is. Like we've seen it mathematically with letters and Greek symbols and so on, and we actually plugged in some numbers and we did it by hand. Now we're just using cells on a spreadsheet. This is just another way to see relative purchasing power parity. So now that we've got the right, we can drag and drop. Excel knows, it picks up the pattern you're doing. See? It says, oh, okay, I see what you're doing. You're taking this guy, multiplying it by this guy divided by 1 plus this guy divided by 100, and that's the output. That's the output in this cell here. Here you go, and it just does it for all of the cells. Up to, again, Excel is really smart. It recognizes where you stop. Okay, so this is my forecast based on purchasing power parity. Okay, I predicted from 1982 in quarter 2, I predicted that the exchange rate in quarter 3, which is this guy here, I predicted that, actually purchasing power parity, relative purchasing power parity, predicted that the exchange rate would be 1.749. What was it actually? It was actually 1.7241. So, using this forecasting method, I was off quite a bit. Let's see, by how much were we off? Let's call this PPP error. Equals what the actual was minus what was predicted. Okay, we're not going to multiply it by 100 or anything like that. We're just a straight up number. And once you get 1, double click, Excel does it all for you. See here, if you look at the function f of x equals b6 minus k6, if you keep your eye on this here, it goes down as we go. b7, k7, b8, blah, 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 blah. And now what we're going to do next is square this column. See, take these guys and square it. Why? Why are we doing? Why are we? We'll call it SQ for squared. Error squared. Why are we squaring it? The reason we're squaring it is because ultimately we're getting forecasts based on purchasing power parity, based on interest rate parity, specifically uncovered interest parity, and then also a naive forecast. And we're going to evaluate. You're going to evaluate in the project. Evaluate which of those 3 models predicts the best. And then you look at that and say, well, how do you judge, how do you evaluate which forecasting model is the best? And you say, well, you can look at the line graph. That's also part of your project. But a more objective way is to look at a statistic, a nice number to look at, to compare. Which has the higher number, lower number? It's lower number. We're going to see which one has the lower root mean squared error. And as the name implied, squared error there is you have to take the errors and square them. So that's what we're going to do here. Take the error here and square it. How do you square something in Excel? Caret, which is the shift in, on my keyboard at least, it's shift and 6 key. So this caret here, raised to the power of what? 2. That's squaring it. And once you do 1, thick white cross, then black cross, double click. Okay, I think I'll stop this video clip here now, and then I'll do the interest rate parity one. Cuts down the size of the file, so